All right, we're good.
Cool. Hey, everybody. Thank you for coming. Today we're going to be taking a deep dive into Lakehouse AI. My name is Nicholas Pelez. I'm a technical product engineer here at Databricks.
My name's Ankit Mathur. I'm a tech lead for model serving on GPUs and for large language models here. Super excited to chat about a deep dive into Lakehouse AI today.
So, quick safety statement here. A lot of the stuff we're going to show you is in various kind of preview stages. So it all does work right now, but make your buying decisions based on generally available things so the lawyers don't get mad at us. All right, so let's start off with a slide that hopefully you've seen a few times throughout the course of the past couple days. Lakehouse AI, a data-centric AI platform. So this is how we kind of think of our AI platform in three kind of big chunks. So we've got data collection and preparation. We've got some kind of model training, building, and then we have to do something with that model. So we have to serve it out and make it useful to our organization and potentially more. And we believe all of this should lay on top of a Unity catalog and on top of a data layer as well, right? So what we like to say is that we have an AI platform that also lives on your data layer. This does a lot of things for you. One, it provides common tooling for all personas. So data scientists, data engineers, your analysts, it gives them all kind of a coherent way to do a lot of the things that they need to do. It provides end-to-end governance, lineage, version control, not just for your data, but for all your AI assets, right? This could be models, this could be features, et cetera. It lets you use a single copy of your data. You don't have different siloed kind of platforms where you have to move data all between them to do things. You can just do it all in one place. It lets models inherit the governance of the data that they're trained on. Gives you system-wide monitoring capabilities, and if you saw the keynote yesterday with Lakehouse IQ, it really lets you leverage lineage and semantic understanding, which you can build on top of to start doing some really interesting things down the line. Something I want to stress is that this is for all kinds of AI assets. This is not just one kind of model. This can be your classical ML algorithms, your regression models, your classifiers, your proprietary LLMs, OpenAI, your open source LLMs, like all the cool stuff you can see on Hugging Face, chains, agents, deep learning models. We do it all on one platform. So I'm going to just kind of quickly walk you through the different pieces of it and kind of how it all helps and all fits together. So at the start, you've got to prepare your data, right? You've got to bring data in. Whether it be batch, streaming, real-time data, or we have kind of world-class data engineering tools that let you bring data in a really consistent and production-ready way. All of this data then goes into Unity catalog and in Delta. This provides your governance, your lineage, and your really performant data storage layer. Then when you go to actually do something with this data, we have really awesome tools that let you train and develop different kinds of AI assets. So we have machine learning runtimes that come preloaded with all sorts of good libraries that you're already likely to be using. And we have MLflow, which is our open source ML platform. That does a whole bunch of awesome things, and you'll see it a lot throughout the demo, but it lets you track and register, deploy, serve all sorts of different models.
But once you've got those models governed and registered and created, you actually also want to use them. And that's actually the most critical part about turning these things into real-time impact. And so Databricks will also help you serve AI assets. That means that your APIs, your BI tools, your ETL or streaming pipelines, these can all consume the outputs of your machine learning models, either in batch or in real time. And it's not just models, by the way. You've got a lot of other things in your Unity catalog, such as features, functions, data. These things are also servable and also usable in your other tools downstream. All of these things can be served as part of the Lakehouse AI platform. But once you've got a living data application with your AI, it's not enough to stop there. You've also got to make sure that application continues to run and operate well, and also that it continues to improve with the feedback that you're able to get by deploying this machine learning asset. And that means that you need monitoring. Part of the Lakehouse AI platform is allowing you to take the logs back from your existing deployments and turn those into metrics, features, and other things that will allow your models to continue to improve over time.
Cool.
Now, there's a lot of different capabilities that are a part of this end-to-end stack. It all starts with notebooks, workflows, DB SQL, Spark, Delta Live Tables, these are tools that you're probably at least somewhat familiar with. But on the machine learning side, there's a lot more as well. Your notebooks are enhanced with machine learning capabilities within Databricks, which means that you can kind of get a lot of those machine learning things as a part of your notebook experience. If you want to start from a higher level interface, we offer AutoML kind of services that allow you to develop models automatically. MLflow allows you to package models and track your experiments and runs. And then when you go to the serving AI side, we've also got a lot of functionality there. We curate a set of models that we actually serve in a really, really optimized way, including a lot of large language models that we can serve at best-in-class throughput and latency. In addition to that, those functions and features that we talked about can also be served as part of your AI platform. And finally, there's the AI gateway, which allows you to use your AI in a governed way with rate limits and configured security rules. On the monitoring side, we actually tie all of this back into the Lakehouse. All of that data from your applications goes back into Delta via Lakehouse monitoring so that you can actually make sure to continually improve those models.
Cool. So, we've done a lot of talking already. Let's actually go and see what this looks like in practice. So we're going to jump in to a workspace. So for those of you who have not seen a Databricks workspace before, this is kind of what you're greeted with at the start. And we're going to start at, kind of the natural starting point. We've got to get some data in here, right? So on the left, we're going to go into Delta Live Tables. So Delta Live Tables is a world-class data engineering tool. It basically lets you orchestrate your workflows and get your data in, whether it's batch, streaming, live data, all in a really, really performant way. So what you're seeing here is a Delta Live Table pipeline. Let's actually go and see what one of these looks like, kind of set up. So we've got a pipeline name. Now we've got a pipeline mode. We're leaving it as triggered, but in a more production setting, you can have this as a continuously running pipeline. Really just kind of depends on what your data tasks are. If you have a nightly process that you might need to run only once a day, then you can save money and just trigger it once. Or if you have some kind of live sensor data you need always running, you can assign the proper resources that way. Then all you pointed to are some notebooks. These notebooks can have either SQL or Python in them. We support both, so whatever you happen to like more, we support it. We'll take a quick look at what those notebooks look like in a second. But one thing I really want to stress here is that if you see this destination section, we are feeding all of this data into Unity Catalog, right? And that's going to be a theme throughout this whole kind of demo, is that Unity Catalog really is this governance layer that tracks lineage and permissions across all of your data and AI assets. And so we're going to be going back to Unity Catalog quite often. So you'll see we've created a catalog named prod demo, and we have a target schema named performance. So let's just take a quick peek into what one of these notebooks look like. If we go back to the run, we can actually just open up one of these notebooks. Now this one happens to be a very pretty notebook, but if we just scroll to the actual code that's being ran, you'll see that it's just SQL queries, right? And you'll see that we've created some live tables. Those live tables are what you see flowing from left to right. It lets you do your transforms. You'll see here we've actually also set some constraints. So for your data engineering pipelines, usually there are some things that you may rely on as far as fields that cannot come through null, or certain variables that might tell you that, hey, this data is either not useful or we want to quarantine it and look at it later. Delta Live Tables lets you do that in an awesome way. So if we go back to our Delta Live Table run, once this whole thing is complete and all the run is finished, let's go into our data tab to see where all of this ends up. So we'll be going back to this data tab a lot, so get used to it, but it's actually really sweet. So if we go to our Unity catalog named prod demo, we go to our performance schema, you'll see that now we have some tables. And you'll see that there's tables of different kinds here, right? So this first table is, I believe, a streaming table, right? We can zoom in a little bit, harder to see. This streaming table came from that DLT pipeline, and because it's in Unity Catalog, we can go into the lineage graph. We can expand our lineage out. We can see where this data came from, where it's going, where it ends up. There's a few more in here somewhere. There it is. Right, so you've got lineage tracking. But you have more than that. So let's say that I also want to give my coworker here, Ankit, permissions to use this table, right? We can easily just assign him permissions. And if we want to be a little bit more, if we want to give him more permissions, we don't have to do it at the table level. We can give him permissions at the schema level or at the entire catalog level as well. So it really gets you that fine-grained control over your data assets. Cool. We've got data in here. Now, the first thing you usually want to do, you can't just go and train a model. You kind of want to understand that data, break it down, and see what's going on with it. So we're going to jump into a notebook. This is what the notebooks look like in Databricks. In this case, you'll see we've attached to a cluster. This cluster is running one of our ML runtimes. That means that a bunch of machine learning packages are pre-installed for us. Saves us a lot of time. Also lets us work consistently with other folks. So let's just take a look at what data exploration, just data science looks like, right? So the first thing we're going to look at, this is all wind turbine data that we're going to be looking at, right? So we can, in this case, use the Pandas API, and we're just going to look at one bad sensor, one good sensor, right? We've got nice inline visualizations. You can see the top sensor, everything's looking nice, it's pretty good. The bottom sensor's got some spikes, right? We can get a little bit more advanced. We can write queries in here. Again, Spark kind of underlies all of this, so you can use Spark, make it all quick and efficient. We have awesome libraries. In this case, we're using Seaborn that's installed in our ML runtime to plot a distribution of a lot of our sensor data, right? And looking at it, it's like, oh, okay, well, there's a signal there, right? We can probably train a model to tell us whether or not a sensor is good or bad, because it looks like there are some pretty telltale signs that a sensor might be bad. Now, in order to give our models the best chance of being, performing well, we also want to create some features. So what we can do is we can take our data and we can do some, say, time averages for these sensors. We can enforce some primary keys, so say an engine ID and a timestamp. Save these as a feature table, right? Now, something that I really want to point out here. When we create our feature table, and we're using the Databricks Feature Store client, there's two things. One, a feature table is really not much different than a normal table. We're just enforcing primary keys. It needs to have a consistent way to look up the features, and those are through our primary keys. But another thing is that when we actually store this feature table, it's going through this three kind of namespace architecture. This is Unity catalog. So prod demo is the catalog that we showed you earlier, where our DLT pipeline was storing data. Performance is that same schema. And we're going to write this as turbine hourly features. So if we go back to our data tab and we open up our Unity catalog, we go to performance and tables, you'll see that our turbine hourly features is simply a table in Unity catalog governed the same way with enforced primary keys, right? We can assign permissions the same way, and if we had given him permissions over the performance schema, then Ankit would not only have permissions to our data, but to this feature table we just created. So we've got data, we've got our features. Now the next step, how will we train a model? So we could start writing a bunch of boilerplate code, or we can go over here to experiments. Again, our goal is to provide people some awesome tooling to be able to do all their AI goodness. And we can create an AutoML experiment. So we can select a cluster. We're going to tell it, we want to classify something. We're going to point it to a data set. And here, again, Unity catalog comes into play. So we can go to prod demo, the catalog we have set up, to our performance schema, and we can give it one of our tables that we created with the DLT pipeline. We're going to tell it a prediction target, in this case, abnormal sensor, right? And then we can actually join in some features. So we can grab a feature table, and again, because it knows everything, right? Turbine ID and hourly timestamp are already on here. You don't even have to tell it. It'll look them up. In our case, we actually don't have to wait for it to run. What AutoML is going to do, let's just go look at a finished run. It will actually go and take your data set and try a whole bunch of different approaches to training models. It'll try different hyperparameters, different model types, and what you end with, close this so you can see all the runs, is a bunch of runs, the models, but also the notebooks that created it. So we take a glass box approach to most things that we do. we don't hide things from you. So we're not only going to train these models, we're actually going to give you the auto-generated notebook that trained the model. So let's go look at what one of those looks like. Actually, before I jump in here, I want to touch on one other thing. We've talked about MLflow a good bit. MLflow is a big underlying reason why this is possible. So MLflow is tracking all of these runs, tracking the models, tracking the notebooks that created the models. And so because we have MLflow kind of baked into the platform, we're able to come up with really cool dashboards and tracking like this. So if we go into this auto-generated notebook, we do a bunch of revision history, and I have made changes, so we're just going to close that. So we're not going to go through every piece of this code because if you can see from that little right-hand bar, there's a lot. But what I want to stress as I scroll through this is that all of this code is time saved for you. This has all been auto-generated. If you want to make sure that it works, you can always go back and verify. But if you're happy with the results of the model, you've basically saved yourself a ton of time writing boilerplate code. So as we get towards the end here, you'll see we have a final trained model. So once we have a final trained model, we're going to use MLflow again to register our model. Why would we register a model? Once we have a model registered, we can use it all across the platform. So we can use it as a Python function. We can use it in our SQL queries. We can build dashboards off of it. So in this case, I want to point out again that we are registering this model to our Unity catalog. So you can see again, we've got the 3 namespaces: prod demo, performance, turbine sensor prediction. And in this case, we're going to label this as the champion model, right? We've kind of gone to a champion challenger architecture for models. And so now, if we go once again back to our data tab, into our Unity catalog, to the performance schema. So before we have all our tables in here, but if we expand here, we also now have a model in the same catalog. And again, permissions, just the same as you were doing earlier, right? If I want to give Ankit here the ability to use this model, I can. Give them all privileges and grant. And the beauty of Unity Catalog is that it's all in one place, your data and your AI assets. So now that we've got one model, trained, tracked, registered, now we can use it in all sorts of places. I want you to imagine that you don't have one turbine. You have a farm. You have a ton of wind turbines all over the country, right? So now, because you have not only your data, but your AI all in the same place, you can actually blend them together and create dashboards that are AI-powered, but also run off of your data layer, right? So you'll see, we can have forecasting models off to the right. We can have interactive maps, so we can zoom in and see where everything is. You can tie it to all your ground truth data, so you can track things like revenue per hour, how many faulty sensors you currently have out in the field, right? And so you've really now baked AI into your platform. But where do you go from here?
So it's one thing to be able to create an operational dashboard and kind of use machine learning to do that. And it's another thing, and even more actionable, to take that and make it into something that changes the way that your business operates and improves it. So here we see this list of wind turbines that we predicted actually needed repair, right? And so what actually happens when something like that happens is that someone has to go out and take a look at it, and those repair technicians have to figure out what's wrong with it. How can we help those people be more effective at their jobs by using AI to help them out? Well, we can do that by building on top of the Lakehouse AI platform. And the first step is to take what data we have and actually make that actionable and useful. So here we see that we've got the turbine ID associated with the turbine that's actually failing. And you might imagine that these things have actually been maintained in the past and have maintenance reports that people need to go read in order to be able to actually diagnose the problem. And so when we go take a look at our data tab again, we can actually see that that data does exist in that same governed manner within the Unity catalog. And so here you can see that there's actually this table with 2 keys, one which is the engine ID and one which is the maintenance record. And so how can we actually make that useful to people? That maintenance record, let's go take a look at what that actually looks like.
Let's dive into it real quick.
So there we go. We're in this notebook now. And when we print that maintenance record, wow, it is long. It's several pages long. I mean, like you can probably keep scrolling. And it is really, really hard to consume that. So how can we actually take the power of large language models and actually make that actionable and useful for people? Well, one thing that those models are good at is actually summarizing. So what if we could actually summarize the maintenance record so that people have an actionable way to go and act on the repair in a faster manner than having to read through pages and pages of reports? And that's where our serving layer can really give a help. So if we click on the serving tab here, you'll see that there's all these endpoints that have this purple lightning bolt next to them. And that indicates that they've been optimized for serving specifically. And the difference between optimizing and not optimizing can be up to 10x in terms of performance. So we're really excited about offering best-in-class serving for large language models in our serving platform. And so here you can see we've got this open source MPT 30 billion model that's served within our serving platform. It's it has permissions, it has all these different features, and you can query it with really, really low latency. So how can we then use that, right? We might want to pass that maintenance record to that endpoint and ask it to summarize it. So let's take a look at actually how you might do that. Well, what do you get in from the user? You just get an engine ID. That's what they've gone to look at. So the first thing you've got to do is perform a feature lookup. So you can actually go get that maintenance record associated with that engine ID. And so here you can see we use our feature store client to actually define a lookup that lets us get that maintenance summary. Now, once we get that summary, all we have to do is actually just call our LLM with the correct instruction that asks it to summarize that maintenance record. And so you can see here we ask it to summarize it in a few concise sentences. And so when we do that, if you scroll down, you can actually see a summary that, a little further, yeah, there we go. We can actually see a pretty concise summary that summarizes what might be wrong with that turbine. And you can see that we suspect the gearbox was overheating. Cool. So how do we now make this an application that our end users can use without having to go and plug in a bunch of different pieces? Well, one more thing that we offer within the Unity catalog is actually a function. And a function can actually be a great piece of glue to help us connect these different pieces.
So right now I'm going back into Unity catalog because we've created this function, right? And I want to just point out here for a second that, again, your registered functions have now made their way into Unity catalog. So again, not just data, but all your AI assets, right? So that function that we created that takes that engine ID as an input, does the online feature store lookup. So, let's say our maintenance team has an online feature store that they've been upkeeping all their maintenance records. The end user doesn't want to go pull maintenance information and go feed it to an LLM, right? They just want to say, hey, I have this engine to go fix. So we take care of all of that. We say, okay, you have an engine ID. We understand where that data goes. We understand where we need to pull the maintenance records from. And we understand that what you're looking for is a summary. And so we can take a prompt that we've written. We can go do the feature store lookup. We can feed our function all the maintenance data along with the prompt, hit our served endpoint, which in this case is MPT30B, right? Super low latency, internal, so your data is not leaving, right? This is self-hosted. You don't have to call a third-party LLM in this case. And so let's actually do a quick slide recap, I think, because there's been a lot that happened here.
Take a step back and see it visually, right? So that's exactly the workflow that Nick just walked you through, right? You've got this raw maintenance data, and what your teams at the end of the day want is a summarized result. And so what we do is we actually will look up that engine ID, get that maintenance record, use our function serving endpoint to call our optimized LLM endpoint, get a great summary of that maintenance record, and then pass that back to our downstream consumers. This is exactly the kind of full data application that we can enable within the Lakehouse because there's a bunch of different pieces here that all need to work together. But they all fit within that exact same governed platform. And so now if you take a look at your system, right, you can actually deploy your live data and AI applications to your whole organization. So you've got, on one side, maybe before this, you have people who are reading a lot of pages and confused. And after this whole system, you can just get a summarized maintenance recommendation and make everyone's job a lot easier. And so this is one step towards hopefully helping people supercharge their powers at their jobs with machine learning and AI.
Now, there's a little bit more to this, right? Which is, we've deployed this. Now, we have this model out there, and our maintenance teams, they might be having a good, grand old time. Now they've got a summary. They've got a good idea of what they have to go fix. But from our point of view, that's not necessarily the end, right? So if we actually go, one thing that we do, and this kind of brings us back, actually it's probably worth pulling these slides back here. If we look at the bottom part, the Lakehouse monitoring part, since we have all of the information for these inferences, and we're storing them all as Delta tables, we can then use these to monitor how our deployed models, deployed functions are actually performing. So imagine that you are these maintainers. You're going out there, and someone gave you a summary, and in this case, it was the very first thing. You went out there, you tried the first thing on that summary, and it fixed it. You're happy, right? Well, you might have a way to then leave some kind of feedback, right? A thumbs up. Hey, that was a good summary, right? Or maybe the opposite. Maybe it was like, you know what? None of these 3 things that you told me were it at all. It was something totally different. So this summary you gave me honestly didn't help me at all. One really cool thing that we're doing is that we surface these tables for you. So this is a dashboard that actually Casey showed earlier in the keynote. So we're using it here as well because it really just paints an awesome picture of what it looks like to have the full end-to-end monitoring platform also integrated. So because we track these feature tables, right, we can now create dashboards that show you how your models are performing out there in production in the field. It gives you a way to also collect feedback. So you can track thumbs up, thumbs down, what was the prompt, what was the response, and maybe the maintainers have a field where they can put in, hey, actually it was X, Y, and Z, right?
And one thing to add there is that all of the data that goes into your endpoints can be transparently logged into a Delta table that actually enables this monitoring to exist, right? We monitor on top of the Lakehouse and on top of Delta. And so each request and each response is tracked with an ID that you can then join back with that same information about the feedback. And you can have all of that data governed and living in the single place, which is within the unique catalog in Delta.
So the beautiful part is that when it all comes together, what you're essentially doing is you're creating your next training data set. You're taking all these inferences that are going out, collecting feedback, storing it all together, and you have all your ground truth data because your data platform is your AI platform. Now all of a sudden, you are creating the very next iteration of the training set that's going to fine-tune that next model that's going to make it so those maintainers that go out there are going to have just that much better chance of hitting the right thing, saving time, and actually doing their job as best as they can. So, to wrap it all up, we like to say that we are building a unified and production-ready AI platform, but we're also democratizing AI for your entire organization. Your maintenance team is part of your model training team now, and they're doing it just through natural language. So that more or less sums up our content, but we figured we'd
love to take your questions.
Open the floor for Q&A.